Continuing along to this next group, notice the next group just asks me to rewrite the problems using radicals or roots. So the question becomes, what kind of root is 3 to the 1/2? Well, remember the type of root that it's going to turn into is determined by the denominator. So that means that this will turn into a square root of the number 3. Technically, it's raised to the first power here, but you don't need to actually write that, so I can just rewrite it as the square root of 3, which is already reduced. You can't go any further than that. The next one, we got 7 to the 2/3. Again, remembering to start with the root on the bottom. The 3 tells us we're looking at a cube root of the 7. Well, notice, again, I do have something besides a 1 there. This time I have a 2, which means that that 7 is actually squared. So there is actually one mathematical step I can do there. I can actually do the math here. I can do the 7 squared, which is 49. So I can rewrite this as the cube root of 49. These two answers are actually equivalent. It just depends on how far they want us to actually go. Let's look at turning C into a radical. Again, starting with the denominator here, which is a 2, means we have a square root. Now notice the entire piece, r plus 2z, is inside of the parentheses, so that will be the whole thing will be inside of your root. So r plus 2z will be inside of the square root. Then that entire thing also has a 3 on top of that fractional exponent, which means the entire thing will also be cubed. So as long as I put parentheses and cube it, it doesn't matter if I put the cube on the inside of the square root or on the outside. I'm just going to go ahead and put it on the outside. So again, I'm used to dealing with the square root first and the exponent second. There's actually nothing you can do beyond this. This cannot be simplified, so you have to leave it just like this, and you are all done. Let's take a look at D. We'll approach it the same way. Again, starting out with the 6 on the bottom means that we're looking at a 6th root of, well, there's parentheses around everything, so that whole piece is going to be inside of that 6th root, so we'll have a 5x squared plus 3z cubed inside of that entire 6th root. Then we can't forget about the 5 on top, which means that that whole thing, when all is said and done, is going to be also raised to the 5th power. What else do we need to worry about? Well, the one last thing we haven't worried about is the negative exponent. They tell us we want positive exponents usually. So if we want positive exponents, how do I get rid of the negative exponent? Remember that I drop it to the bottom of a fraction. Well, there was nothing else there next to our negative exponent, so the only thing there on top then should be a hidden 1. So our final answer is 1 over the 6th root of 5x squared plus 3z cubed, and then that whole piece is also raised to the 5th power. This next group of examples has us again using our little trick that roots can be turned into rational. Remember, the word rational is just a fancy way of telling us that it can turn it into a fractional exponent. So they're giving us a hint. Remember, when we do this, the base stays the same. So in this first example, they're giving us a hint that this 5, the base will stay the same. Remember that the type of root is a square root, and the root goes on the bottom of our fractional exponent. So if it's a square root here, the type of root will be a 2 on the denominator. The regular exponent, the 10, will go on top. So that 10 will go on top. So right now we have a 5 to the 10 over 2. Well, what do we know about 10 over 2? 10 over 2 is just a regular fraction that can be reduced. 10 over 2 reduces to 5, so we will get a 5 to the 5th power. And it depends on what they want us to do, but unless they tell us we have access to a calculator, we would leave 5 to the 5th as is, unless they tell us to go ahead and figure out that answer using a calculator. Let's look at another one. We've got a square root of x to the 8th, y to the 4th. Again, we've got a square root, which means there's a hidden 2, which means I can rewrite all of these as fractional exponents. Well, that means we've got an x and a y. What would be the fractional exponents? Well, the root, remember the square root, the 2 would go on the bottom. Your regular exponents, which are the, let's see, the 8 and the 4 would go on top. Well, those reduce. Well, 8 over 2 on this x reduces to a 4, so that's x to the 4th. And y to the, well, let's look at the y piece. That has a 4 over 2, which is just 2. So when we have a square root, it's just the same as taking the exponents and dividing them by 2 because the root goes on the bottom. So that means we can continue to do this. On the next problem, we've got a root of 3. It means all those exponents will have a 3 on the bottom. It means we're going to divide them by a 3. So, well, first, starting out with the x term, we have a 6th power that'll get divided by 3, which will give me 2. Now looking at the y term, well, the y has a 12 on it, which divided by the 3, the root, would give me a 4th power. And now looking at the z, which has a 33 as its exponent, again divided by the root of 3 would give me an 11. So that gives me x squared, y to the 4th, and z to the 11th. And that is my final answer. Again, we're lucky because all of these divide out evenly. Let's continue. On the next one, we have a 4th root. So that means, again, we're going to be taking all the exponents and dividing them by a 4, which luckily they all divide evenly. So let's start out with the x. Well, taking the x term, which has a 4, 4 divided by 4 would actually give you an x to the 1st power. Then moving right along to y, y has a 16. Well, 4 goes into 16 4 times, so that'd give me a y to the 4th. And lastly, we would have a z. Well, we have a z to the, let's see, 64, which divided by the 4 would actually give us a 16. Now, the only thing that we actually do not have to write is the 1 exponent on the x to the 1st here. So I can rewrite this as just x, y to the 4th, z to the 16th. And again, we were lucky on this one again because the root 4 divided evenly into all the exponents, to the 4, the 16, and the 64.